Morning everyone. So what I thought I'd do today is just talk you through some of the concepts for Mr. Colatis's work around bit rate and baud rate. What I've done is taken the Craig and Dave video, and what I've decided to do is let the video run and then explain different parts as it comes around. So I hope this is useful. Okay, so first of all, we're just going to go forward through protocol and get on to bitrate and baud rate, because I'm sure you all know about protocols. Okay, so let's have a look at the slide here. So if we just stop it there for a second, I think you know this. So bit rate's not the term that people get confused with. So that is the number of bits transferred per second. It's the baud rate that causes the problem. So let's just have a look at what they say about that. So what they're saying here, if we remember sound. So if, for example, you only have one bit to represent a sound, then you know that the sound that you will capture will either be a 0 or a 1. And it's the same here. It's basically saying that one bit will be transmitted on each signal change. Now, this will become clearer when we look at more than one bit being transmitted. So if we look on this one, what we can see here is that each time the signal changes, because we have more voltages available, more bits can be represented. So instead of just having two voltages available, which means one bit can be represented, then what we're saying here is while the signal change, duration hasn't changed, because we've got more than one voltage available, each voltage or each level can represent 3 bits. So it means that if we have a low voltage here, instead of it just being 1, 0, it can now be 0, 0, 0. Instead of this voltage representing 1, it now represents 0, 0, 1. And then as you can see, so we go on. So it'd be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So that means every time we change the signal, because we can expect to see more than one voltage, then we can actually map that onto a 3-bit pattern as opposed to a 1-bit. So that means in this case, because the baud rate is higher, we get more bits for our time. So if we look here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 signal changes. On the previous slide, that would have been 9 bits. But now what we have is, of course, 27 bits being transmitted in the same time. So the baud rate being increased means that the bit rate does increase also. So to increase the transmission rate, we could increase the baud rate. The bit rate is still the same as the baud rate saying there. So let's have a look at what they say around that. So just looking at what they're saying there. So what they're saying around this, to increase the transmission rate, we could increase the baud rate. So that's just simply meaning that we can increase the number of signals sent in a specific time. So if we look here, we've got 9 signals sent. It's saying let's send 18 signals. So we double the baud rate. But in that case, if you're only using 1 bit per signal change, it means the bit rate equals the baud rate. If we, however, represent more voltages, instead of increasing the amount of time, which may not be feasible on a specific cable, so we might not be able to increase the rate of change, i.e. change the signal twice as fast. Instead, what we're saying is we can increase the number of voltages that we read, and therefore if we can read 4 voltages, then we can send 2 bits per signal change, and if we can read 8 voltages, we can send 3 bits per signal change. So without changing the time of the signal change, i.e. this duration here, so how quickly the signal changes, we have tripled the number of bits that are being sent because we've increased the number of voltages. So I hope that really helps with your understanding around bit rate and baud rate, because it is a tricky one.